Assalamualaikum and greetings everyone. I am Dura Izabiti Muhammad Razim, a final year student in Bachelor of Science Honours in Applied Chemistry. To all the panels and viewers, welcome to my final year project presentation with the title of The Physicochemical Properties and Treatment of Oxidized Coal and High Sulfur Coal. I am supervised by my lecturer, Dr. Siti Nolia binti Ali. In introduction, I will cover the background of study, the problem statement, the research questions, the significance of the study, the objective of the study, and also the scope of the study. Let's get into the background of study. Coal is a brownish-black sedimentary rock consists of carbon, oxygen, hydrogen, nitrogen, and sulfur. It is a form of fossil fuels and is known as a non-renewable energy. In high-quality coal, there are high amount of carbon, low amount of sulfur and oxygen. Vice versa to the low-quality coal, it has a low amount of carbon and high amount of oxygen and sulfur. Both of these oxygen and sulfur content are an undesirable content in coal. Its presence affects the coal's quality and the environment due to the spontaneous combustion and sulfurous gases. Moving on to the problem statement. Oxidized coal could release heat that will lead to spontaneous combustion. This combustion discharges poisonous gases such as carbon dioxide, also known as a heat-trapping gas. Meanwhile, in coke-making industry, the properties and quality of cokes has changed. For high-sulfur coal, the combustion could release sulfur oxides. This will then lead to the phenomenon of acid rain, acidification of soil, and also affect humans' respiratory system. These are the research questions in this study. The first one is to know what are the characteristics of oxidized coal and high sulfur coal. Second, what are the forms of oxygen and sulfur components in coal. Third, how does the characteristics of oxidized coal and high sulfur coal affect their usage. Fourth, what are the treatments of oxidized coal, and lastly, what are the treatments of high sulfur coal. All of this will be then discussed in literature review section. This study is significant for us to understand the physical-chemical properties that has changed for oxidized and high sulfur coal. Along with that, the treatments on both coals should be done in order to increase the coal's quality. Therefore, the limited usage of the coals will be minimized. The aim of the study is to review on the characteristics of oxidized coal and high sulfur coal, along with the methods to treat both coals. This study includes the influence of high oxygen and high sulfur towards the coal's properties and how these properties would limit their usage. Also, a treatment of both coals are included. In literature review, the topics that will be discussed are the oxidized coal, the high sulfur coal, the properties of both coals, the effects of its usage, and also the treatments for both coals. Oxidized coal is the coal that is exposed to the environment or coal that has been mined or stored for a long period of time. It consists of oxygen-containing functional groups such as carboxyl, phenolic, alcoholic, and hydroxyl groups. To give example, lignite and subbituminous are a kind of oxidized coal. The properties of oxidized coal has changed compared to raw coals. It has lower aliphatic carbon chains and lower calorific value. The swelling degree and cross-linking density is increasing, as well as the pore size. Oxidized coal also affected the coal thermal plasticity. The usage of oxidized coal will somehow cause spontaneous combustion and release the carbon dioxide and leads to global warming. When oxidized coal is used, the coke quality will decrease along with the coke plant's productivity. Due to the existence of oxygen-containing functional group on coal surface, the floatability of coal is decreasing. The treatment is important in increasing the coal's quality and improving the environment's quality. To treat oxidized coal, there are two ways that have been reviewed, which are by using ionic liquid and deep eutectic solvent. In a previous study from Mo et al. 2020, ionic liquid 1-octyl-3-methylimidazolium acetate is used to swell the coal and disrupt the hydrogen. New bonds between hydrogen and hydroxyl are generated in order to reduce the carbon-oxygen bonds. Therefore, it will reduce the oxygen-containing functional group in coal. While a previous study from Fatma and Bernaji 2019, deep eutectic solvent formed by mixing 1 to 2 molar ratio of choline chloride and urea is used. This solvent is a well-established hydrogen interaction with a greater melting point depression. In this study, the results showed a reduced oxygen-containing functional group in the FTIR peaks. As compared to ionic liquid, deep eutectic solvent is easy to prepare and a low-cost solvent. Continuing with high sulfur coal. Sulfur may be found in fresh water, seawater, plants, and mineral substances. It can be classified into two, which are inorganic and organic sulfur. For inorganic sulfur, the examples are like pyritic sulfur, sulfate sulfur, and elemental sulfur, while for organic sulfur, the examples are like mercaptans, thiophene, sulfoxides, sulfones, and sulfur ethers. To be recognized as high sulfur coal, the sulfur content needs to be higher than 3%. The changes in properties of high sulfur coal includes the lower calorific value, lower aromatization degree of coal structure, lower coal maturity, and also lower hydrocarbon chain. The combustion of high sulfur coal could release poisonous gas like sulfur oxides. This gas acts as a threat to the environment, causing acid rain as well as humans' health. During combustion, the operational issues happen including slagging, boiler fouling, and rusting. In a fuel reactor, it also affects the CO2 compression, storage, and transport. In treating high sulfur coals, there are three methods reviewed, which are by using physical, chemical, and biological desulfurization. A study from Xia et al. 2018 undergo a physical desulfurization by using coal pyrolysis with lowered iron powder and dry magnetic separation. When the pyrolysis temperature is 500 degrees Celsius, the sulfur content in coal is recorded as 1.2%. However, when the pyrolysis temperature changed to 700 degrees Celsius, the sulfur content reduced to 0.7%. For chemical desulfurization, Su et al. 2020 used ionic liquid, 1-carboxymethyl 3-methylimidazolium hydrogen sulfate as extractant, and hydrogen peroxide as oxidant, with a molar ratio of 1 to 10. The total sulfur removal in a coal is reported as 45.12% and the organic sulfur removed is 16.26%. Lastly, for biological desulfurization. According to a study from Su et al. 2020, bacteria strains T. ferrooxidans, E. coli, and P. putida are used. It is reported that P. putida act as the dominating strain. In 10 days, with a particle size ranging from -125 to 75 meter, pH of 6, inoculum of 25 ml, twin 80, concentration of 0.1%, and 1 hour of ultrasonication, the total removal rate of sulfur is 58.23%. Lastly, let's move on to the conclusions and recommendation. In conclusion, we knew that coal is still being used in the global market, but the high oxygen and high sulfur contents in coal give bad effects on the environment. Moreover, it also changed the properties of the coal. Therefore, the two ways have been reviewed in treating oxidized coal by using ionic liquid and deep eutectic solvents, while for high sulfur coal is by using physical, chemical, and biological desulfurization. To be concluded, the treatment using deep eutectic solvent is the best treatment for oxidized coal due to the environmentally friendly and low-cost solvent. While for high sulfur coal, it's best using biological desulfurization due to the high percent of removal rate and it consumes low energy and is easy to use. In future study, it is recommended to do a research thoroughly on the physical cleaning on coal by ultrasound treatments because it enables to eliminate the thin clay layer and oxidized layer from the oxidized surface of coal. Apart from that, ionic liquid can also aid coal desulfurization, but it is rarely used. Hence, a future research on the chemical desulfurization mechanism is beneficial since it is more efficient, pollution-free, and low cost. That's all from me. Thank you and have a great day.